Hello, my math friends. This is Mrs. Schlecht. And in this video, we're going to talk about equations, expressions, and solutions. All right, my math friends, you know that before we get started, there's a few things you need in order to be successful for this activity. First, you're going to need your Envision book, still volume 1, with our robot friend on the front. Second, you're going to need your math notebook to take those beautiful math notes. Third, you're going to need a pencil. And fourth, last but certainly never ever least, my friends, that positive math attitude. All right, my friends, so this video goes very well with lesson 4-1, which is the very first lesson of topic 4 in your Envision book. The key concepts page is on page 188. Okay, so before we get into like the super cool math that is lesson 4-1, there's a couple of words that we need to go over first, all right? Expression and equation. All right, my friends, so first, let's talk about this word expression. All of these are examples of expressions. So we have 16 times 3. We have 3f, so 3 is a coefficient, f is a variable. Over here, we got 14 minus 3 plus 8. We got 21 times w plus 17. We got 4 plus 9, right? So all of these, my friends, are expressions. The biggest thing to notice about expressions is that there's no answer here, right? I have some math. I got some math language going on, right? I know that in this expression, it's telling me to take the quantity of 16 and multiply it by 3 or have 3 groups of that 16, right? Over here, it's telling me to take this quantity of f, which I don't know, again, it's an unknown, but then I'm multiplying it by 3, right? So these expressions express an idea, but it doesn't actually give us like a solid answer quite yet. So if an expression expresses an idea, an equation tells you what it's equal to. So you'll notice all of these down here are equations. And how I know they're equations is because they have this handy dandy little equal sign. Get it? Equation, equal. Kind of samesies, right? So over here we have 1 times 7, that equals 7. This is a complete equation because it's balanced, right? It's telling me this information is the same, equivalent, it's equal to this side, right? So we know that 3 times 5 is 15, equal to 15. Boom, that's an equation. Over here we have 20 divided by 10 equals 2. It's got that equals 2. Boom, that's an equation. Over here, we have 10 divided by 2 equals 5. Again, it has that equal sign. That makes it an equation. So again, my friends, expressions, there's no equal sign. It just expresses an idea. It tells me kind of what I'm supposed to be doing, but it doesn't actually give me an answer, right? An equation tells me what it's equal to. All right, my friends, so we just talked about equations, and we said that an equation has to have that equal sign to show us that it is an equation. So over here, I have an example of an equation, right? We have 3f plus 2 equals 17, all right? So this is an equation again because I have that equal sign, right? That tells me that this side of my equation is the same as 17, right? Now let's talk about this word solution, all right? Solution is referring to this little variable, that letter f. And what it wants to know is, what's the solution for f that would make this whole thing true? So let's just try a couple of different scenarios and see if those are actually the solutions. All right, my friends, so over here, you'll notice that I gave f 3 different values, right? So either f equals 2, f equals 5, or f equals 7. I don't know which one of these is a solution to this equation, but what we're going to do, my friends, is plug in these different values for f, and then let's see if we're able to get 17. All right, so let's see which one of these solutions is actually going to work for this equation. So I first started with f equals 2 because that's what, the first one was. So I take this equation that we've already established, and I'm now going to plug in the number 2 whenever I see an f. So now we actually have 3 times 2 plus 2, and I need that to equal 17. But it does not equal 17, and I can prove it to you. I know that 3 times 2 is 6, and then 6 plus 2 would actually be 8, right? But now let's look at this little equation that we have down here. So over here, this equation is telling me that 8 is equal to 17. And I don't know about you, but I'm pretty sure that is not correct. Now, how do I show that 17 and 8 are not equal? I just draw a line right through that equal sign, and that means not equal. So now is it true that 8 is not equal to 17? Yeah, that's accurate. But what that also means is that f being equal to 2 is not a solution to this equation. All right, so we already discovered that f equals 2, not a solution for this equation. So now let's look at the second possible solution. That means f is equal to 5. So what I've done over here, my friends, I took our equation and now I'm just substituting 5 for our variable, which was f. So now we'll have 3 times 5 plus 2. We know that 3 times 5 is actually 15, so we actually have 15 plus 2, which would get us 17. Now, is 17 equal to 17? Yeah, all day long, all the way, totally, right? So that tells me, my friends, that 5 is, yes, that is a solution to this equation. So we know that 5 is, yes, that is totally a solution to this equation, but let's just make sure that 7 is not also sneaking in there as a solution as well. So I take my same equation, but now I'm substituting 7 instead of 5. And when I have 3 times 7 plus 2, we know that that actually works out to 21 plus 2, which will give me 23. Now, does 23 equal 17? Nope. So how do we represent that? We put a line right through that equal sign, right? And that tells us that 23 not equal to 17. What that also means, my friends, is that 7 is not a solution to our equation. All right, my friends, so now it's time to get into that Envision book and start having a whole bunch of fun. So the first problem that we're going to look at together is on page 188, and it's number 5. So number 5, very similar to that example that we just looked at. We have d plus 9 equals 35. And then over here, our book gives us 4 different possible solutions. D equals 16, D equals 22, D equals 26, or D equals 36. And the idea, my friends, that we're trying to figure out, well, which solution for D will actually make this equation true? The first solution was 16, but I know that 16 plus 9 actually equals 25. It's not equal to 35. Therefore, 16, not a solution. The second possible solution was 22. But when I do 22 plus 9, my answer is actually 31, which is not equal to 35. Therefore, 22, not a solution. Our third solution, we were trying 26. Now, is 26 a solution to this equation? Oh, yeah, all the way. Look at this. When I have 26 plus 9, that equals 35, and I'm pretty sure that 35 equals 35, so yes, 26 is a solution for this equation. So the next example I'd like to look at together is still on page 188, and it's number 6. So same setup as those last problems, my friends. It gives us an equation. So we have 14n. Remember, that means multiplication. So 14 times n, and I want this to be equal to 35. And here are our possible solutions. Either n equals 2, n equals 3, n equals 3.5, that's 3 5/10, or n equals 4. So now, my friends, we're just going to start plugging in our values and see if any of these are actual solutions to that equation. Make that first substitution with a possible solution. Number 2, we have 14 times 2. Does that equal 35? It does not, unfortunately, my friends. 14 times 2 equals 28. And you know, 28, 35, not the same. Therefore, they are not equal. So 2 is not a solution. Possible solution was 3. But when I plugged it in, I know that 14 times 3, actually 42, not 35. Therefore, nope, they are not equal. Therefore, 3 is not a solution to this equation. 3 not a solution? Let's try 3.5. But when I do 14 times 3.5, or 3 5/10, my answer is actually 49. And again, 49, 35, not the same. They're not equivalent. Therefore, 3.5, not a solution to this equation. Lastly, my friends, the last possible solution we had was 4. But when I plug in 4 to this equation, I have 14 times 4. That actually equals 56. And again, my friends, we know that 56, 35, not the same number. Therefore, 4 is also not a solution to this equation. Did you notice that all of those different solutions that we tried were not possible solutions to this equation? And that's okay. We can answer that and say, nope, none of these solutions are the correct solution for this equation. And we proved it, right, by showing what each of these solutions would actually be equivalent to if we plugged it in. And we learned it's never going to equal 35. Friends, so again, that was just a quick run through of lesson 4-1, which again goes over our equations and their solutions. As always, if you have any other questions, please let me know.